Okay, so today we're going to be presenting the chameleon versus fabric transformers for image recognition. My name is Absidy.
My name is Alexander.
My name is German.
Go.
So first off, we wanted to talk about an analysis of the project as a whole, and kind of run through some hypotheses. So the first one being, we believe that the accuracy of runtime of the experiment will have little to no change when we're using a VPN to change the location. The second hypothesis was Fabric Portal and Command Cloud will have similar accuracy/runtime. So while implementing this experiment, we did run into some challenges. First, we tried to run the experiment just like it was given to us, and then space quickly became an issue. So we decided to create a slice to resolve the problem. And then the last challenge was we weren't able to request enough disk space on the slice. So next I'll show you what that looked like first. So here you could see we did node A and node B, and we tried to change the name of the slice, and we were still coming up with the slice failed. On the next slide, you can also see node C and node D, and we were still receiving the error.
So we tried contacting the Fabric forums to see if we could get any help. They told us the project owner had to request some resources for us, but that had its own issues and we couldn't end up getting the resources, which leads us to a small experiment instead. Since we could not run the experiment on Fabric, we decided to do a small experiment on Chameleon without any GPUs. That way it's kind of a simulation on Fabric since there's no clear way of getting those resources. So we did that on Chameleon without any GPUs, and our expectation is for the SSH server to crash. So surprisingly, the server did not crash, but it ran at a much slower rate without any GPUs. For it to reach a batch size of 2,200, which is less than halfway, it took about 8 hours. So an estimate, it would have taken 16 hours for it to finish, meaning it'd be very impractical to run without any GPUs.
Oh.
Although we did have success with Chameleon Cloud, but we did run into some challenges, which we'll cover in a little bit. One being a reservation of the lease itself, to not access the SSH server, and a long runtime. Since getting the lease through Jupyter Hub has a lot of problems, we had to do it with the Chameleon website, allowing us to get a lot more control over it. Otherwise, it gets deleted due to idle time and the restart of the kernel.
So in order to access the SSH server, we needed a key pair. And in order to access a Jupyter Hub file within the SSH server, we needed to run that server on our local machine. This became an issue because Jupyter files do not provide a key pair. The solution we came up with is we assigned a floating IP to ourselves. So when we ran the experiment, one of the things we weren't expecting to find is that the fine-tooth model had a ridiculously long runtime of almost 8 hours, with there still being more to do. So the solution we came up with is we use the ResNet and VIT models. So here we have our Chameleon outputs without the VPN. So on our left, we have the ResNet models, and we have the VIT model on our right. This is where you cut, starting now in 3, 2, 1, go. So one of the things we did after we started running the experiment, we used several different VPN locations to see how it would affect our results. So as it became very apparent, it did not affect the accuracy as it stayed the same for each VPN model. However, our times did change, with the ResNet time only differentiating by a couple of seconds, no more than a minute at most, with the VIT accuracy with the VIT time changing again by like only 5 seconds. So both Fabric and Chameleon have their benefits and they have their downsides. Fabric being a much friendlier user environment, a great tool for teaching and for learning. And it's also a great place to do quick, small experiments. Chameleon, by comparison, tends to be far more intimidating for beginners with its UI, but it also has much higher computational power. For our experiment, we found that VPN location does not really have much of an effect towards the output of the results, with the runtime being only a couple of seconds apart from each other, with the accuracy not being affected at all. We'll just redo another one.
Yeah, this is practice. So yeah, so basically I'll just talk about here. So I'll start here. So basically, in order to run the experiment, first you want to go into the Chameleon website, and go to one of your projects, and you would want to create a lease here. Once you start creating a lease, once you start, don't know where those came from. Once you start creating a lease, you want to put a name, and since you're gonna be using a high resource to run the experiment, you'll most likely have to get it in a couple days. For this simulation, we're just gonna use some cheap resources, so we're not gonna get any GPUs. So then I'll just create a lease. So I'll show him doing that. Once the lease is completed, after that, you'll just want to come over here, go to your instances. And this is where you'll want to create an instance. Once you finish creating an instance, you want to make sure that you choose shared net. This will allow you to actually attach a floating IP. And also you want to make sure you include a key so that you can actually access the server itself. So this is where you'll create the instance. And once the instance starts to run and finishes running, you'll want to attach a floating IP to it. And this is where you create a key pair if you don't know how to do that. And it'll download onto your computer. Keep a note where that's located. After that, you go to floating IPs, and you'll attach one of these into one of your actual servers, into your instance. Once you do that, you're going to have to wait a little bit, a couple minutes, as it's setting up the actual SSH. After that, you're going to want to go to this is where I'm gonna have to pull up the other the app.
Yep.
Oh,
That's the nice thing, is this is the time that this takes a bit.
yeah.
We just cut this out. And
Okay, so then you'll want to pull out your Bitwise SSH client. And this is where you'll type in your IP. And then this is always going to be CC. And then you'll want to import your key onto here. The way you import it is by going to your host key manager. Well, hold on. No, I think it's here. Oh, yeah, no, not host key, client key. But you want to go to your client key manager and you'll want to import it here. Once you import it, it will be named as like one of these globals. Then you want to make sure that the correct global for the correct SSH, and then you want to log in. Once you log in, you'll open the terminal, and this is where you'll want to run all of the commands that you need to run in order to set up the GPUs so that you can use it. So then this is where I have to show them the commands now. So this is the file we will be using for the commands. This is a file provided by the actual project that we're using. Most of this first part you can ignore since this is what creating leases, but we just already did that manually. You'll want to start from here, install stuff. Since we're doing it manually, you'll want to download these three. Then these, while ignoring this one, you don't want to install that one. Then you want to reboot. Then install these three, and then reboot, then install this. And then after installing all of that, you can set up your Jupyter Hub server. After setting up your Jupyter Hub server, you'll have access to the actual experiment with the GPUs by running this on your SSH client and a local terminal. And then yeah, I've basically just been showing all of that in the process. Just showing up the actual installing all of this and that kind of thing.
Okay. And the nice thing is you don't need to run it.
No, yeah, I'm not gonna run the actual experiment. That takes
I think that goes over the 15 minutes, and we're about to get kicked out any moment.